Okay, so question 4 is about working out the area of the shadow of like this shape and comparing it to the area of the shadow when it's upside down if all the sun's rays are parallel, right? So the claim is the shadow is literally just these two circles, okay? And you draw like their common tangent, right? And it's everything above the bottom tangent, but like to the right of the big circle, right? Like to the right of this bit and to the left of this bit and below the top tangent, yeah? So that's the area of the shadow, okay? And the area of both shadows is just, this is the other way around, but the distance between the centers is the same, yeah?
The centers are the same.
Yeah. So the areas with, if you, the visible areas are really, like if you don't count the visible shadow, like the total shadow has the same area, yeah? So then the visible shadow is just the total shadow minus the base, yeah?
Total shadow minus the base. Okay. Oh yeah, the base
So
is just
obviously the
like.
bigger base is minusing more, so it has a lesser visible shadow, yeah?
Oh, okay.
Okay, so how did we prove that? So this is where you got to pay attention and not do your other things. You understand? If you do your other things, you can't come back and say this wasn't done. Okay? So basically what happens is we're saying that because the lines are all parallel, the shadow is just a translation of that shape to the plane on the ground, yeah? Okay. And then but there's also like the other parts of the shape. So there's like this circle here, right? And that makes a shadow like that. Okay. And so then we're saying the shadow is like a union of all all these circles, yeah?
Mm-hmm.
Okay. And then we're saying that so these circles all have center that lie on one line, right? Linearly centered. Because the center line through all the circles is cast the shadow over the center line of these circles. Yeah? Okay. And um then we're saying that all of these circles have a common tangent on both sides. Yeah. And if that's what we if and once we can prove that, yeah, that proves the shadow has to be this because if the shadow touches the tangent, then that point on the tangent is on the shadow, right? Okay. And if the circles are all tangent, it means it doesn't go past the tangent, right? So it means
Mm-hmm.
that things below the tangent are not in the shadow. Yeah. So that's exactly what we want, right?
And the question is how to prove that.
Okay, and how did we prove that, right? So then we got, so like if we take the circles, so instead of looking at the common tangents, if we look at like sort of these radii, diameters that are perpendicular to the center line, right? Yes. Then if you join the endpoints like that, okay, then those lines will be where the diameters of the circles touch. So like if a circle has center here, then this is the diameter. Yeah? That makes sense? Okay. So well we know this because this line is um this line is sort of the shadow of so these purple lines are the shadows of these purple lines. Okay? Yes. So it's clear that the shadow of a straight segment is also straight, yeah. So it just suffices to check that 2 points lie on those things, okay? Okay, so we know that, and then what do we want to do is we want to prove that the common tangent of this circle in the middle is also the common tangent to the two red circles. Yeah. So if you miss this, don't ask again, okay? So this common tangent. So the difference now is that the radii are 90 degrees this way. Yeah? Yeah? Okay, so we want to show that if this is little r, this is little r, this is big R, and this is big R, right? And this is x and this is y, right? Then we want to show x equals y, okay? And then it's a tangent as well, yeah? Okay, how do we do that? Well, we have three parallel lines here. So these are all parallel, right? We also have these blue lines are parallel, yeah? So that means, so if we label these segments like A, B, C, D, E, F, right? What that means is like E over F is equal to C over D is equal to A over B, right? Okay, and that's also equivalent to like E over E plus F equals C over C plus D equals A over A plus B. Okay? Alright. And then, so then what we have is, if we just zoom in on the X, so if we have like this, this, like this is little r, this is big R, this is like X, alright? Then, this is E, this is F, this is C, this is D, right? Then we can move this one across to here, right? And then this length is still C, this is still D, right? And the point is, these are similar triangles, so then x over r minus r, so x minus r over r minus r, is equal to e over e plus f, yeah? Okay. Okay, and then if we do the same thing for y, right, for the bottom thing, we get that y minus r over r minus r is equal to c on c plus d, right? Okay, but we just said that these two are equal, okay? So that means these two are equal, so that means x equals y. Yeah? Does that make sense? Yeah, so that's a full explanation, right? So, you could go a little bit more in depth, because we cleaned up that to that detail. We could probably go a little bit more in depth with the translation of the shape, right? I guess the important thing to note is that it's not like a point source of light and the rays are coming out like that, right? Because if that was the case, things would get bigger, right? But if they're all parallel, then they're kind of staying the same size, you know?
Oh.
So the lengths are preserved. So so it suffices to show the like the circles. Yeah, it preserves the length, I guess. Okay. Any questions? Yeah, I mean, if there's anything more to be said here, it could be said about the translation. Okay. But you can think about that a bit more as well.
The